Hello, everyone. Thank you for joining us today for this important webinar on digital transformation and energy transition in the oil and gas education. As the Young Professionals Chair for the SPE Uganda section, it's a privilege to host you all and to have you all, being such a talented number of individuals who are eager to learn and engage at the same time. In a rapidly changing energy landscape, digital transformation is not just a trend, but it is essential for enhancing efficiency and sustainability. Our discussions today will focus on how we can harness new technologies and innovative practices to drive our industry forward. I'm excited to hear from our esteemed speakers who will be sharing their expertise and insights. I encourage all of us to participate actively, ask questions, and share all our ideas with the rest of the team. That will be all from my side for now. I hand over back to the moderator. Thank you all.
Welcome. Thank you, Andrew, for that insightful address. And I would like to use this moment to welcome everyone for making time to come and attend this webinar. We are excited to have a diverse panel of experts with us who will be sharing their insights on digital transformation, energy transition technologies impacting the oil and gas education landscape. Joining me today, we have Dr. Victoria Nalule, Dr. Yen Adam, Dr. Joan Namukasa and Micky Ofori Kuragu. We are looking forward to have a lively discussion, and feel free to drop your questions in the chat. We shall address them during the Q&A session. And without further ado, allow me to introduce our first speaker, Dr. Victoria Nalule. Doctor, I am very honored to introduce Dr. Victoria Nalule. She's the founder and chief executive for Nalule Energy and Minerals Consultant. Dr. Nalule holds a PhD in International Energy Law and Policy from the University of Dundee and lectures on natural resources law at University of Bradford, UK. A prolific author, Dr. Nalule has published 8 books and numerous articles on energy transition, renewable energy, oil, gas, climate change, and mining. Her expertise continue to shape the energy policies globally, and we are privileged to have her with us today. Please join me as we welcome Dr. Victoria. Please, Doctor, take over.
I'll be addressing some of the questions that were sent to me. And the first one is basically to talk about what the energy transition means. And then the second one that I'll be addressing is risks of not adopting oil and gas education to include energy transition trends, and how could this impact the future of the oil and gas industry in Uganda. And then the other one is the key competences or skill gap in the area of energy transition that are missing among young professionals. So we're all talking about the energy transition everywhere, which is a good thing. But then the most important thing is to understand what this transition means. Most people would view the energy transition, or we understand the energy transition as a shift from dirty fuels to cleaner energies like renewable energy, or it's a way of decarbonizing the energy sector. And this has come to be accepted globally as one of the solutions to address climate change. We are all aware of the 2015 Paris Agreement and the various obligations from member parties. We are aware of the UN SDG 13 on climate action. So those are some of the basic principles or the basis for this energy transition. But however, whereas we're trying to address climate change, and whereas we need to decarbonize the energy sector, we also have to ask ourselves one question, especially for developing countries. How will this transition impact on different countries? And most discussions globally, including like the conferences we attend, even us here, because I'm based in the UK right now, where I do lecture, the energy transition is often presented as having only opportunities. And that's, yeah, there are some opportunities there. And the first one, as we might all be aware, is to address climate change, to decarbonize the energy sector, because obviously we are seeing the negative impacts associated with climate change. We're seeing the floodings in different countries. We're seeing droughts even in African countries. We're seeing migrations, a lot of refugees, people leaving their homes because of the impacts associated with climate change. So that makes it a very urgent challenge, which would require us to take urgent measures to address this climate change. And one of them is to decarbonize the energy sector. That is by shifting from fossil fuels, including oil, gas, and coal, to cleaner forms of energy, including renewables, solar, wind energy, and so forth. However, if you look at the UN SDG 7 on energy access, you realize that sometimes it becomes hard for us to universally access modern energy if we are going to have this wholesome transition. And by wholesome transition, we are looking at immediately or even considering to leave behind certain types of energy that are considered to be dirty. So if we have a wholesome energy transition, and that is what most of the climate change activists are advocating for, it will be disastrous to developing countries, especially countries that have not yet addressed their energy challenges. And remember, energy is very key for the economic development of any country. I was just coming from our first stakeholder validation workshop in South Sudan, where I'm leading on the development of the energy transition strategy for the extractive industries of South Sudan. And you realize, like, countries like South Sudan, whereas we want to put in place the energy transition strategy, we also have to be aware of the economic challenges, the social challenges, the political challenges in that country, and develop a strategy that will ensure that the country is not left behind. So in summary, yes, the energy transition might mean a shift from fossil fuels to renewables, but then for developing countries, they could consider the alternatives to that energy transition. That is something that I introduced as the energy progression, so that you do not follow the crowd. You do not follow what every international organization is telling you, what every developed country is telling you. You need to develop your own pathway to transition, to progress from one energy use to another in a way that will not be detrimental to your own people, in a way that will not be detrimental to your economic development. So for me, that's what I call the energy progression. And whereas I have written extensively about the energy transition, I'm also aware of the risks that are associated with this transition if we do not closely look at it. So I'll address the question as to why it's important to include the energy transition trends in the education system. First, it's for the young professionals to know or even to appreciate what is the practical impact of this transition. Because if you're only focused on the energy sector and fossil fuels, obviously it's playing a big role in Uganda, in Ghana, in South Sudan, and in different countries. If you're only focused on that, you're going to miss out on some of the opportunities that this transition might present, especially for young for young professionals, what kind of training, what kind of skills do you need for you to be able to tap into this new market? Because yes, the energy transition presents lots of opportunities, and one of them are the job opportunities for people who are now getting expertise in hydrogen, getting expertise in renewable energy technologies. It's going to be very essential, because at the end of the day, the transition is there to stay. That's the truth. It's there to stay. So the earlier, the better for people to understand this transition, and also for the young generation to get the necessary skills, to be aware of the various technologies that are needed, and also, most importantly, to apply those skills in their own countries, in their own communities. So that's the main thing of incorporating the energy transition trends and also expertise in the education system. And then I'll address the question, because I was also asked to talk about the challenges when it comes to incorporating the energy, the clean energy technologies like carbon capture, or even incorporating them, but also embracing them in different countries. The first challenge, obviously, is the issue of some of these technologies are very expensive. Not every country can afford it. So for countries, especially developing countries that already have enough challenges, we have like health care challenges in our countries. Obviously, you have energy challenges, you have economic challenges where most people are really finding it hard to even feed themselves. It becomes hard for a government now to invest in these clean technologies, which are mostly scarce. And because they are scarce, they're also very expensive. So there's that financial commitment, there's that financial barrier that makes it hard for developing countries that are already experiencing various challenges to be able to incorporate these technologies in their countries. So that's the main barrier. And then the other thing is also when it comes to the monopoly, when it comes to these technologies, you realize that most companies that have access to these technologies are from the developed world. So the developing countries, we are just recipients of these technologies. But if we can also take initiatives to be able to manufacture like solar panels, to be able to come up with our own technologies to solve these challenges, it would become easy for us to even have tailored solutions that align with our unique energy challenges, that align with our unique climate change challenges. Otherwise, if we're just going to follow the international community, follow the developed world of what solutions they are having for us to embrace them, it raises a gap because we shall always be followers. So for the young professionals, as we're talking about the energy transition, especially people who are in science, engineering, this is your time to shine, to come up with these unique solutions, unique technologies that are fit for the African continent. Otherwise, it's not always good to be a follower, because you end up being misled. When a country comes up with a solution, they come up with that technology. If it doesn't work out, then you also have to fail at the same time, because you're just following whatever solution that are being brought. So in summary, that's the summary of my presentation. But after the presentation, I will share some of my recent publications on the energy transition and its impact on the African extractive industry. I'll share it with the organizers so that they can be able to share with all of you. But for now, I'll stop here and let my other panelists to also present. Thank you very much.
Thank you, Doctor, for sharing your valuable insights on the energy transition and the role the law is shaping, the role of the law in shaping the future for the sector. Your expertise truly gives us a broader perspective on the challenges and the opportunities in this space, as you've shared. As Africans, we have to have like a Silicon Valley here, other than always depending on other countries. Up next, I am pleased to introduce our second keynote speaker, Dr. Yen Adam. Dr. Yen is a senior lecturer and the head of department of Petroleum Engineering at Kwame Nkrumah University of Science and Technology in Ghana. He is also the principal research lead at the Net Zero Carbon Emission Lab, focusing on groundbreaking research in net zero GHG solutions, carbon capture, utilization and storage, and green enhanced oil recovery. Prior to his current role, Dr. Yen served as an assistant professor in natural gas engineering at the University of Stavanger in Norway, and he holds a PhD and master's in petroleum engineering from the University of Stavanger in Norway, and along with his BSc in petroleum engineering from Kwame Nkrumah University in Ghana. Dr. Yen's extensive experience in green technologies and his research on carbon capture make him a key thought leader in the sustainable energy solutions, and we are privileged to have him with us today. Over to you, Dr. Yen.
Thank you very much, Madam, for the introduction. Can I share my screen so I could go through a very brief presentation?
Yes, please, you can go ahead.
The system is not allowing me to share. So can you kindly check that for me? All right, please, is my screen visible?
Yes, it is, Doctor.
Yes, it is.
Okay. Yeah, then I'll start the presentation. It's going to be brief, but basically, I've built my presentation around stories. So first, I'm going to look at how over the years I have built my career around, although I'm a petroleum engineer, I've built a career around the energy transition. And I think there are some aspects of my career that could be a motivation to some of our students. So I'm going to talk about that. And then I also look at our story as a department of petroleum engineering. I'm also the head. So I would like to take us through some of the things that we are doing here and the measures we've put in place to ensure that our students are not left out of this opportunity. And then finally, a little bit about what our future holds. All right, so I have all my education in petroleum engineering as introduced by the moderator. I had both my master's and PhD at the University of Stavanger in Norway, and I hold a BSc degree in petroleum engineering from KNUST Ghana. Now, the reason why I've listed this here is because I found out that many students tend to feel that acquiring degrees in petroleum engineering makes you an anti-energy transition person. So I put it here so that I show you that you can still do very well as someone who advances energy transition, even with a petroleum engineering degree. Now, in terms of digitalization, I went to graduate school at a time that programming was very important in Europe, but it wasn't so important in Ghana. So I had an undergraduate degree here that I didn't know much about computer programming. I could do a few things with computers, but not much. So in graduate school, I think the first course that I was required to code was geostatistics. And we were made to code in Excel VBA and use some advanced Excel tools. So I had to learn that quickly from scratch. And after picking that skill and using it in the course, I learned how to code in VBA. Then I moved on to learn MATLAB. So by the time I was done with my master's, I could code in MATLAB. Then I picked up, Python was coming up. So I jumped on that. And then by the time I was done with graduate school, I was not only programming, but I was using these tools in computational modeling and simulation of very complex challenges. Now, so when I returned here to Ghana in 2019 to start working, I decided to find a way that I could teach these students to code. But we have very large classes. I mean, the students on average at that time was about 100 students in a class. And the maximum number of students that I had taught in Norway were about 25. So it was quite difficult for me to teach, but I taught around it. And then I designed a very effective method for teaching digital skills. Now, if they are my students on the platform, some of them could look at it and they will be able to talk a bit about how I was able to do that. We didn't have much computers for all these 100 students, so there's no way you can put all of them into the computer room. So we had to design around their own computers. So I teach a concept, and then I build a project that the students will take home, so that those who do not have computers can even borrow computers to work on the projects. And by so doing, over the years, I have seen increased number of our students doing very well in their digital skills. Now, myself, I publish a lot in using digital tools, including machine learning and other advanced tools in my publication. At least I have about 5 papers in that area. Now, I did, in terms of decarbonization, I did my PhD in carbon capture and storage. So for 4 years, I was in the lab flooding core samples with CO2 and particles. Now, there's a gas plant in Stavanger called the Reservika gas plant. Now, at the point, the time that I was going into my PhD, the gas plant had a challenge. They saw that the gas that was being transported had some particles in it. So there was a research proposal to find out if we could develop models to characterize CO2 and particle flow concurrently in reservoir rocks. So I won that project, got the scholarship, and then that's what I worked on for 4 years, getting my PhD. So by the time I was done, I learned a lot about carbon capture and storage, and also about greenhouse gas emission in general. I have published over 20 papers in CCS. That is my main specialization, and so most of my publication is in that area. And so I also decided to build that into my work. So I learned programming and digital tools, build that into my work, design a way to bring it into my teaching. I think that is very important for me and for sharing with young people, because later on I'll bring that back. Then I did CCS, I came back here and decided to develop a course that is focused on energy transition. So I developed a course called Energy and Climate Change. And I've been teaching that on a project-based learning scheme. And most of the students truly enjoy that course. I'll speak a bit about it later if there's enough time. Now, in terms of capacity building, now I teach the programming course in second year. And I make the students use it a bit in third year when I teach numerical modeling. And then in final year, I try to bring the programming back into reservoir simulation. So they use it throughout. And so by the time they are in final year, they are ready to use it. Then when I teach energy and climate change, I find a way to incorporate digitalization and energy transition. So I develop project topics, some of them I'll show you soon, that the students will have to apply the digital tools to solve these problems, challenges in energy transition. So later on, I saw that the interest of students in this area became very significant. So I decided to start the Net Zero Carbon Emission Lab last year, together with my colleagues here in the department. And this lab is solely focused on providing expertise, technology development, especially capacity building. And our focus is on decarbonizing oil and gas. And we've been doing a lot with our students. Now, this is my profile. If you look at the papers that I've published in 2024 alone, they are mostly in CCUS and a little bit on greenhouse gas emission assessment. So that is my specialty. Now, these are some of the project topics that I've been designing and implementing with students. In 2023, I did 3, and I think I had about 14 or 17 students in total. And all the 3 topics are in CCUS. If you consider the first topic here, it says design of a data-driven multi-objective criteria for screening CCUS storage facilities in Ghana. It has so much in it. It has the digital part in it, because here a student will have to develop a tool that uses machine learning to screen a reservoir to find out if it is suitable for carbon storage or not. So he has to understand a bit about energy transition. He has to understand a bit about using, deploying these digital tools. And I saw that they had great interest in that. And all the topics you see here will require students to at least use some of these skills. And by the time they are done, mostly they learn a lot. Then these are some of the topics we did this year. I had about 27 students or so in 5 groups. And if you can check through the topics, all of them require some level of programming, especially the second one. You see development of AI-powered net zero emissions tracker for the Ghana energy sector. Doesn't sound petroleum, but there's so much in it for a petroleum engineer to learn and deploy his skills. If later you want to discuss that, we can look at that as well. Now, these are some selected ongoing projects that I'm working on. We are working on a CO2 storage resource assessment project together with GMPC. We are trying to assess our 4 geological basins to find out if they are suitable for CO2 storage. And I'm also working with CCG, Climate Compatible Growth, to conduct a carbon emission assessment of KNUST and put it on a map so that we can track our emissions as an institution. Now, let's look at a little bit. That is all for my story as a person. Now, I'm going to go through our department, how we have evolved over the years in terms of the energy transition a bit. Now, since 2004, we have been running a BSc Petroleum Engineering program. We have been running the program before oil and gas was found in Ghana. Now, initially, the program was focused on helping students to develop core engineering skills and domain petroleum engineering skills, because the country found oil and we just wanted to train people who could be trained easily by companies to work. So we ran that curriculum for a while, but in 2020, we started a new curriculum because we realized that the energy landscape was changing. And so we started a new curriculum, and the new curriculum was heavy on digital skills, because most of our clients, especially the companies, were beginning to complain about the soft skills of students. So we developed this course that gives students IT from first year down to final year. And then that continued. But in 2021, we did a stakeholder engagement. to find out if energy transition was a priority for the oil and gas industry in Ghana, and the response was not very encouraging. So we didn't develop a curriculum that was extensive on energy transition, but we focused our curriculum on developing high digital skills, especially energy and climate change course. And I added that as an elective in final year. So that is a course that teaches students to conduct carbon emission assessment of various oil and gas operations. And then after they have conducted the assessment, the goal is that they will be able to propose solutions. So it gives them awareness of every operation, how they can assess their carbon footprint. And over the years, the interest of students in these tools, especially these courses, grew tremendously. So last year, we started NCEL, which I've described a bit, to help build more capacity. And then this year, we developed a new curriculum that is very heavy on energy transition. I'll talk about that a bit later. Now, the petroleum industry today, we see it to be split or to be focused in three main areas. We still have the oil and gas operations, the traditional oil and gas, very important. But again, the industry is every petroleum curriculum today. If you want petroleum engineering to become useful, it has to somehow have these components. Now, if you look at the top 10 oil and gas companies globally, all of them are doing something in these areas. You look at them enhancing traditional oil and gas operations, deploying CCUS, supplying liquids and gases for energy transition, and transitioning from fuel to energy companies. So they are doing so much. Now, if we, academia, will be relevant, we should even be ahead, because we should train before the companies use. But since they are ahead already, the least we can do is to develop our students to be able to fit into their goals. So a modern petroleum engineering program should have the domain petroleum engineering, general energy systems engineering, decarbonization and renewables, strong digital technology, and strong engineering core. So these are the 5 areas that we have built our new curriculum on. Now, these are the aspects of our curriculum that makes the courses quite different. Now, first, the goal is to produce all-round engineers who fit into the dynamic industry. So we have the engineering core, digital technology, petroleum engineering, energy systems engineering, and decarbonization technology. All these are in the curriculum. Then we are giving flexibility to students for the first time. You know, previously, all students come, they take petroleum engineering, they take the same set of courses, maybe 1 or 2 electives in final year, and they just graduate. Now we are doing things different. So from 3rd year, a student can decide to have a major and a minor. So you can take more energy systems engineering courses and become a major in energy systems and a minor in petroleum engineering. Or you can take more petroleum engineering courses, be a major petroleum engineer and a minor energy systems engineer. So you have a good overview of all the operations, and you can fit in into any of the aspects. And then in addition, we are ensuring continuity. One difficult thing that students face is if they learn something and they are not able to use it. So if a student is taught IT in first year, first semester, and then the second year there's a gap, so what we are doing in this current curriculum is to ensure continuity of all these skills right from first year to final year, so that every semester there's at least some concept that the student is required to bring back what he has learned in the previous year and continue to build upon that and grow. So the emphasis is on growth and development, and our target is still the oil and gas industry, but oil and gas companies are also going into decarbonization. So we are looking at pushing some of our graduates into decarbonization companies and energy sector institutions. All right, so we have MSc Petroleum Energy Systems Engineering, likely to start next year. They are all undergoing accreditation now. BSc Petroleum Energy and Energy Systems Engineering, top up for the distance learning, those who cannot be on campus. And then we have a diploma for technicians who want to take this course. The MSc is fully online, and the target is young professionals who are already in industry to be able to take advanced petroleum engineering courses alongside energy transition and digitalization courses. So we have machine learning, AI, we have offshore wind, we have carbon capture, utilization and storage, hydrogen storage. They are all in this MSc program. And it's an amazing program that when it comes on board, I think most young professionals would want to enroll. Now, these are the challenges that we face: staff training and development. Now, I have a background in carbon capture and storage. So energy transition is not new to me when I came here. Learning something in that area is very effortless for me because I have the schemas that I can build upon to learn anything new. It is not the same for every staff. So we need resources to help staff to develop new specializations in this area so that we can teach the curriculums that we are developing. Then we need resources, laboratory resources, to help our student projects. We also need funded research projects. When you have funded research projects, it's not just about money. It's about legitimacy of the project. For a company to put money on a research project, it has to be really good. And we need that kind of research projects for our students to work on. Because if a research project is really good and a student is put on it, he gets to learn much more. And also, the resources that he needs to do his work becomes easier for him to get because there's funding. Then we need internship and national service opportunities for the students who are specializing in the energy transition so that they don't get stranded. We want companies to give us fixed slots so that we recommend students who are doing well in these areas for them to go in. Now, I end with these 3 ideas for young professionals. Number 1, petroleum is not anti-energy transition. So be hopeful. I've seen that many students are acquiring bachelor's degree in petroleum engineering want to divert to other areas. It's great if that is your ambition, but you don't need to run away because you think oil and gas is coming to an end. You have to be hopeful. Number 2, focus on the fundamental, perfect the fundamentals. The fundamentals will serve you well later. If the fundamentals are good, you can learn anything on it. Okay, so there's no point if you don't know how to use, for example, Excel very well. There's no point trying to learn VBA. The first thing is to get your hands perfected with the basic skills before you build upon that. So you learn the skills that are common. Then once you begin to build some mastery in that, you see the limitations. Then you bring new tools that fill into those limitations and you grow. Then finally, practice what you learn. Seek honest feedback and improve. I learned so many things in graduate school. I don't think I have used more than 20% of what I learned in graduate school since I came here. But I have had joy in practicing them, and I've seen the life of many students transform by what we have been able to put together here. So with this, thank you so much for bearing with me through this presentation.
All right, thank you, Dr. Ian. And one thing I've really learned from this is being open-minded and having a growth mindset. Don't stop learning, don't stop educating yourself, get more education, take those certifications and be better. Your research is really, truly very great, and it's crucial to our industry. Ladies and gentlemen, would like to apologize. It appears we're experiencing some technical difficulties due to unauthorized access, but please bear with us. We're working to resolve the issue. Your safety and privacy are our top priority, and we are taking immediate steps to secure the meeting, and we shall continue as as planned. Okay. Our next speaker, allow me to introduce Micky Ofori Kuragu, production application specialist at Tullow Oil with over a decade in experience in oil and gas industry. Mike has specialized in supporting and managing IT systems, particularly focusing on the AVE, VA, PI software suite, ensuring optimum functionality in oil and gas operations. He holds a master's degree in management information systems and a bachelor's degree in computer science and statistics, both of which contribute to his extensive expertise in streaming digital operations within the energy sector. So we are excited to hear from you today. Micky, over to you.
Hi, hello everyone. Am I audible?
Loud and clear.
Great. Try and share my screen. I must commend Dr. Yen on his presentation. He's covered quite a few of the topic that I was going to cover. And in fact, I might have to change some things on the fly as I go along. Let me just get my screen sharing going. Okay. Right, so my name is Micky. As moderator said, I've been with Tullow for 10 years, a bit over 10 years. I've been in the workforce about 14 years now. And I trust technology to always feel when you need it to work properly. Okay, there we go. Right. So I started my career primarily in the IT space, and then I extended my skills and expertise into supporting the subsurface team, looking after Petrel, Eclipse, OFM, and now I look after production applications such as Pi, Energysys, and Axis. And I must say the digital transformation has changed the landscape for me immensely. So when years ago, when I started in this space, the demands we faced were, I want faster computers, I want better processing power, I want better graphics, I want more storage, I want bigger screens. Now, users usually want dashboards that will consolidate information from various applications and give them information that is relevant to their work. Users want systems to do the heavy lifting for them and give them what they actually need to make decisions with. What this means for us techies is that we must find and or build one of few systems that will interface with many others and interpret data that is there, producing information for the users. And users also want to be able to access these dashboards remotely and from anywhere. They also want to work from home. And this means that tech people must work to make systems available in all sorts of scenarios, and we must do this securely and sustainably. Now, what I've learned over the years in my career is it has been useful for me to understand what my users are doing in the oil and gas space on the day-to-day. And it's been useful for me to teach them how to resolve common issues that we face in the tech space as well. This saves us both a lot of time and effort and makes us both more efficient at our jobs. Would it have been beneficial if my computer science degree had incorporated some oil and gas? Definitely. Would it be useful if the oil and gas engineers were trained in digital technology? Absolutely, as Dr. Yen has said he's been doing with his team. And would it be useful if we both could integrate this knowledge with energy transition? Certainly. And so these are the ideas I'll be exploring in my presentation as we go along. And I'm starting with my conclusion in this presentation because I want to draw attention to what the goal is, what you're working towards. So I'm starting from the end to the front. So here I'm going to cover a few of the tools that we are currently using in the oil and gas space, the tech tools in the oil and gas space that's shaping traditional fossil fuels. So first, AI and ML, we hear about it a lot. It's still quite in its infancy. It's loud now because it's the rave, it's what everyone's talking about, and it's still pretty new. And most of it is in its conceptual stage. However, there are a few cases where AI and ML, AI is artificial intelligence, ML is machine learning, pretty obvious there. So one of the ways that we use machine learning is to process historical data to predict when transmitters will fail. and that's helping maintenance engineers plan for replacements. Now, the transmitters are devices, they are machines. They work for how they break down through wear and tear and so on. What this means is machine learning is able to predict when these failures will happen, and it reduces cost and improves safety because you're not replacing these instruments too soon or too late. Too soon being we are not sure when it will expire, when it will fail, so we'll take it off the field and put another one in. Maybe it has a month of life left. And then too late is when we wait for it to break down. And at that point, we are threatening the integrity of our environment. We also use machine learning to resolve slugging. Now, Tullow has tested Amazon's machine learning tools to predict slugging. Slugging is the accumulation of water and oil and condensate in a gas pipeline. So you have little sludge pockets forming in your pipeline, and this often leads to blockages in the pipeline, and it means that a production must stop to resolve the slugging, which we do with a tool called a pig. And this also means that we are spending time that we could be using to produce gas. And how we're handling this now is, before we did the test, is that engineers would close the valves soon after the slugging has happened, so reactively after it's happened, after the fact, or we would close the valves a bit to reduce flow rates and sort of to preempt slugging and stop it from having a major impact. Now, after we fed 6 months of data into Amazon's machine learning tool, we found that the tool could predict severe slugging events up to 10 hours ahead of time with 80% accuracy. Now, this means that we could leave operations to run at full capacity, and we will be able to tell the slugging is about to happen 10 hours ahead of time. And that's more than enough time to resolve the slugging components, the sludges that form in the pipeline before they become an issue and stop production. For IoT and real-time data, so oil and gas installations rely on numerous sensors, for several purposes. These include drilling sensors for locating wells, sensors for monitoring pressure, temperature, and flow rates in our pipelines. We use cameras for trapper operations. We use thermal monitoring for oil tanker offloads. Now, these sensors typically need to be monitored manually, so someone has to be present on the field to read data from these devices. With IoT, we're able to do this remotely over the internet. So we have a guy who's doing this who can sit at home and monitor these sensors from his laptop. And it just makes things more efficient, easier to operate. For automation and robotics, automation in our industry typically refers to control systems. Control systems are systems or set of devices that manage commands and direct behaviors of other devices and systems. So sort of one ring to rule them all kind of situation. And an example is a process control system that monitors and controls valves and can adjust flow rates automatically. Another is a safety control system that monitors pressure and temperature sensors and gas detection systems as well. And these perform automated actions based on triggers. So if there's a gas leak, these systems will trigger an action and close off areas or close a valve and so on, various applications there. ROV stands for remote operated vehicle. Now, these are unoccupied underwater machines that can explore ocean depths while being controlled from someone on the surface. Now, these are used primarily for operations, installations, and maintenance, and even sometimes search and rescue efforts. And these make it possible and safer to reach remote areas. RVI here stands for Remote Visual Inspection. So what we use this for in Tullow, so this is a web-based virtual platform that we've used to build a digital twin of FPSOs. A digital twin is just a digital version of a real-world object. So how we've done this is we've used laser scans and 360-degree AG photography. This means we built a very detailed virtual 3D model of our vessels. And this digital twin allows us to carry out remote visual inspections of pressure systems and structures. And this results in overall improved understanding of the integrity of assets, and also allows us to detect problems with assets ahead of time. We can resolve them. So we see them early, resolve them early, and avoid problems. Now, there are other benefits of this that I can't cover here because of time, but I can cover later in questions. So energy transition, this is happening whether we like it or not. And as Dr. Yen has said, it is not yet at a stage where it can totally replace traditional oil and gas. The two will have to coexist for a while. If you just look up the product of oil and gas and what to use them for, you will realize it will take quite a while to replace these, to find alternative sources to produce these items, and that's just not happening anytime soon. But in order to harness this transition, and argue the only way to do it is to develop professionals who understand how to balance and integrate traditional fuels with new and cleaner alternatives. This means the next generation of oil and gas workers must understand not only traditional technologies like drilling and refining, but also renewable energy sources and how they integrate into the overall energy system. I'll go one step further to point out that it is not enough to know these technologies. And as Dr. Yen has said, this is why I said he put a lot of holes in my presentation. It is not enough to know just these technologies, so petroleum engineering and renewable energies. You also have to have an understanding of the technology behind them that's driving these changes. So all the systems and processes we use, AI tools, machine learning, 3D printing, advanced computing technologies, all these over time will get better, will improve and get more efficient. And the more efficient these technologies are, the more efficient we are at interpreting data that comes out of this. So, for example, solar panels will become more efficient at capturing solar energy. Batteries will become more efficient at storing energy, and maybe even wind turbines will become more effective at effective and maybe require less energy, less wind force to turn. And even the oil and gas, traditional oil and gas field itself will become more efficient as these technologies evolve. So again, it will not be enough for the oil and gas worker to simply know about or be skilled at traditional oil and gas, petroleum engineering, or renewables. You have to be able to blend technology that you are using in these areas that in the industry itself is adopting to facilitate their progress and their objectives. The current challenge that I've come across in preparing and researching this, and I think this is an area that Dr. Yen has also found and is actually doing something about. So there are lots of curriculum that's focused on traditional oil and gas. And actually before this, I had a conversation with my friends from school, and we were talking about why we felt that a computer science degree seemed like a waste of time when we were doing it and when we were done with it. And we came to the conclusion that this was mainly because the practical applications of the concepts we were taught were not, or the real world applications were not made known to us at the time. And so it all felt out of touch with what you knew for the time soon after you graduated. This is changing a bit, I think. There are many programs that still focus on traditional oil and gas, and there are also many programs that focus on renewable energy. University of Energy and Natural Resources in Ghana, for example, has a bachelor's degree in renewable energy and a master's and a PhD in sustainability as well. But again, if you are not including the digital transformation or technologies that are being used in these areas in your education, then when you graduate, you may feel like you wasted the time a bit doing these courses because this is where the world is going. You could do traditional oil and gas and thrive, you'd be fine. You could do renewables, energy sustainability, you'd be fine. You could do technology alone, you'd be fine. But this creates silos of knowledge, and the industries will have to then have 3 people saying this. It may not be good for employment, but all the same, and industry may have to have 3 people to do a job that 1 person could do. So again, with the challenges, even if you do get these degrees, if the industry is not open up to give people experience through internships or other sorts of engagements, then you'll find that you don't have a lot of real experience to try your knowledge on. So you're able to practice what you're learning, and that makes it more difficult to learn. Also, people learn by doing, and really in petroleum engineering, if you learn only the theory without being able to practice what you learned, it's kind of difficult to progress your career. Again, as I was saying before, you have people, if you're not working to bridge these gaps, you have people being experts in specific areas, and then there's no intersection of the skills, and therefore you have issues with industry as you go forward. So proposed solutions would be, I found a lot of, well, not a lot, but I did find degrees that combine law with oil and gas law degrees that are tailored to oil and gas contracts. There are also IT law degrees that are tailored to law in the IT field. There's supply chain management for oil and gas as well. And you find several courses on renewable energy, sustainability, clean energy, and all. But again, referencing Dr. Yen's presentation, I was going to say that, and I did struggle to find courses that merge IT programs that are tailored to oil and gas. I did find one by Robert Gordon University. I forget the name, but it was a master's in IT for oil and gas or something of the sort, and it has the typical IT course structure, and then 2 courses: introduction to oil and gas, introduction to something else. But looking at the course structure, I haven't taken a course, but I have my doubts as to how effective that course would be in developing an individual who's skilled and can combine IT with oil and gas right out of school. And again, as Dr. Ian was saying, if industry partners with academia, then you have opportunities given to students to practice what they learn. They can come on board internships, national service that we do in Ghana. I don't know what it's done in Uganda after school, but basically you can have some experience during your education, soon after, and that gives you some experience and makes you a valuable resource to the industry. And this also for industry means that they're building a value chain of human resource and a workforce. So if they invest in first developing the criteria with lecturers and academia, and then provide opportunities for students to get hands-on experience, they are enabling an environment where they have a crop of students they can pick from to achieve their objectives. And this is a win-win for everybody. We could also employ virtual reality and simulations to give you a hands-on experience. And again, as Dr. Yen said, the only thing constant in this world is change. So it is not enough to simply do these things, put one-time effort into it and leave it alone. You have to continuously improve. The industry is improving as we go along. It's not waiting for academia or anybody else to try new things and find cheaper ways of doing things or more efficient ways of doing things. So we have to constantly evolve ourselves as along with the industry to keep up to date and abreast with technology. For those of us who are done with school or don't want to go back to do a degree 1 to 4 years, you can pick up some of this knowledge through online courses. These are available on Coursera, Udemy, edX. I know AWS and Microsoft Azure have courses themselves on their technology and how it integrates with oil and gas. AWS too, that I mentioned earlier before. I think it's Sage, forget the name, Sage something. but it's a machine learning tool, and there's a course on it you can take and learn more and see how you can use it in your space. So going back to my last and first slide, I'd like to share a story that a former exploration manager shared with us when he was at Tullow. So when he was coming up as a reservoir engineer, they did seismic interpretation on, well, it was a little different from how we do it now. They would have a large printout of a seismic volume and on a boardroom size table. And at that time, only the senior engineers would be allowed close to the table to do the interpretation. The juniors would have to stand at a distance and observe and only learn by watching the seniors work. And this was because printing out these sheets were expensive. So they could only have 1 or 2 copies, and they were doing the interpretation by hand. So pencils and rulers and markers and whatnot. So you're actively drawing lines. You talk a bit about what you should do. You draw a line back and forth to measure 5 times, cut once, kind of approach. And that was then. Today, at least when I started with Tullow, actually not when I started, a lot after when I started with the subsurface team, we have computers that are available to junior and senior engineers alike. So now the junior engineers have seismic volumes available to them to do work with. They can make mistakes on purpose or accidentally, learn from them and grow and develop. So it's easier for people, or it was easier then for people to learn new things, learn new skills, and they are developing faster than the project manager did when he came up as a engineer. Now, seeing how this has evolved from his time to my time, it is not unrealistic to expect that or to think that in the future we could be submitting these reservoir volumes to an AI to do the interpretation. Feed it the data, tell it we want to know so and so from these reservoirs. We want to know if there are hydrocarbons here or not, or in what volumes. It probably can do that for us. It could maybe even predict when and where hydrocarbons will form, or where the next reservoirs will be, and how many years into the future. So this is just talking about traditional oil and gas. Imagine what the prospects are for energy transitions if you're able to harness and blend skills from petroleum engineering, renewable energy, and technology in the same space and move forward. And that brings me to the end of my presentation. If there are any questions, I'm happy to take them now.
All right, thank you, Micky. I'm seeing a recurring theme, and that is having a growth mindset. Growth mindset with learn new technologies, and share opportunities, take up opportunities you have. It's really insightful and very helpful for our members. Now, as we conclude, the next speaker needs no introduction. We are delighted to welcome Engineer Joan Namukasa. Engineer Joan is a seasoned business leader in the energy sector with extensive international experience in engineering, project and post management, and operational efficiency programs. High expertise spans materials, logistics, quality audits, and assurance, with hands-on experience in technically challenging deep water offshore operations, as well as remote offshore operations in challenging stakeholder environments. We are very privileged to have Engineer Joan with us today to share her vast knowledge and experience. Please take over, Engineer. Okay. As we wait for engineer to come on. Okay, engineer, you can go ahead. You've been made co-host.
Oh, okay, finally. Oops. Etiseng and Akwaba to the Ghanaian family, and welcome to the Ugandan family. Namukasa Kamia is my name. The introduction has already been given. The Ghanaians used to call me 2 years ago, 3 years ago, they used to call me Nana Esi Ajimani the first. So because of the different name combination. It's a pleasure to be here with you guys and to share on incorporating digital transformation and the energy transition technologies in oil and gas education and the training for sustained industry relevance. First of all, if we are to look at the education itself and training, the difference is that education is long-term. You're acquiring information over a period of time to broaden your intellectual and personal development, while training is skills focused. So you're training to get a specialized skill that enables you to be able to execute a specific task. Now, when we go into energy transition, like I've said, the whole topic is quite rich. It has like 3 things in there. We have digital transformation, we have energy transition, we have sustainable industry relevance. And of course, when we bring in education and training, it becomes a cocktail of a rich topic. Now, if we come to transition, for example, if we are to begin there, for me, what I have seen in terms of trends, we are seeing a huge number of people concentrating on the energy transition technologies, which are targeting the automotive industry and demonizing, of course, the fossil fuel. But if you're going to target the automotive fuel in terms of energy transition, we have to be cognizant of the fact that this is only 20% in terms of the usage of the fossil fuel. Now, the interesting part comes in here, that 75% of the usage of the fossil fuel, again, is in petrochemical industry, where you find your agrochemicals, you find your detergents, you find your medical equipment, the expertise in terms of your renewable energy. And of course, you look at your paint, your home furnitures, and a lot of sports equipment. So you really have to be able to talk about energy transition in the entire 100% entirety of the usage in terms of fossil fuels. Again, a lot has been said by my panelists, and me being the last person to speak, it makes my work easier. But if we are to remain competitive in the oil and gas workforce, we need to blend. And this is to the young ones and also those who are still in school, but or continuing professionals, or even the old people like myself. We have to blend the traditional expertise together with cutting edge skills. And this shift basically requires us to redesign the curriculum and focus on things to do with automation. We focus on things to do with data analytics, carbon capture, and of course, the integration of the alternative energy solutions into the existing framework, which we have, the existing infrastructure, and definitely embracing this change. We shall see ourselves being more agile and resilient to the workforce, which is capable of addressing both technological challenges and, of course, looking at the sustainability goals that are defined for what we call the future of the energy industry. Now, we were told to look at some of the competencies that we must acquire, or one must acquire, to be able to stay relevant in the industry. And of course, when we come to talk about digitalization and transformation in that area, if we are to look at digitalization competencies, what should a young professional in oil and gas look for? And those that are continuing within the industry, how do we reshell ourselves and rebrand ourselves and be able to fit in the ever-changing world? Again, we are looking at data analytics and, of course, big data. You have to be able to analyze large data sets to optimize the operations, because you're receiving quite a lot from either the subsurface or the surface engineering, whatever you're doing and whichever field you're in. You'll forgive me, I'm going to be more biased at drilling because that's where my expertise is, but then you can relate depending on the field of expertise that you're in. Again, if we talk about digitalization competences, we are looking at artificial intelligence and machine learning. Now, you have to acquire artificial intelligence, whether you want it or not, and machine learning. These are going to be very essential, and currently are very essential, because we are seeing automating processes, we are seeing predictive maintenance, and of course, we are seeing a need and a drive towards improving operational efficiencies. And these are being brought in by AI and machine learning. Today, we had, just as we logged in, we had a cyber attack. Again, we have to look at the skills. You're not going to only be able to do your work, or you have to be able to integrate things to do with cybersecurity and putting together digital infrastructure. As it grows, you need to secure your assets from cyber attacks. If you're going into a real-time monitoring center or real-time training centers or real-time operations centers, how do you protect yourself against cyber threats? This is going to be another competence that we need to incorporate within the oil and gas industry. We know that recently, I think 2 years ago, there was an offload that happened in one of the pipelines in either Gulf of Mexico, where we had, they were called, let me borrow a word, mafias, who channeled the production into another vessel, and it offloaded because, again, they were dealing with automation and robots and then cyber security threats. Now, we are running automations and robots. Again, you have to look at the competence in terms of the automation technologies. How are you going to run robotic process automation within your oil and gas industry, but also focusing on your exact job where you are? You need to be quite innovative. If there is a robot that is potentially going to take up the work you're doing, how do you strategize yourself? Either you make the robot yourself, you code the robot yourself, you manufacture it, or you are able to interpret whichever data it's bringing to you. So you need to equip yourself with that. Then we have a monster, which I like to feed mostly, is the cloud computing and the edge computing. You will see and appreciate that most of the companies that are into heavy data storing most of their information on cloud. Now, that we are calling it information, but it's usually data, and data which is uninterpreted is useless. So as you're taking your data and your ones and zeros to the cloud, how are you able to bring it back to you, to inform you, to give you information that you're able to use? Now, as a young professional in oil and gas, what is your part? How do you strategically place yourself in between the changing competencies that I have given about, and be able to either be part of it or be erased out. So we have another interesting thing, which is called the Internet of Things. Everything nowadays is smart. We are going to have smart oil fields, which are run by themselves. They are integrated on your phones and on your pads. You can, speak from here and you're communicating with someone in the field, someone offshore. You're able to read real-time information and be able to manage and connect several devices or monitors into your operations. So in that Internet of Things integration within the oil and gas, as a young professional, you have to think predictively and focus in the future and say, where do I lie and what kind of skills do I need to get to be able to fit with this evolving industry. Again, my colleague Micky looked at the digital twin technology. Definitely you're having replicas of your physical assets in terms of whether you're running simulations, doing performance engineering monitoring, and of course you're looking at predictive analytics. In terms of sustainability competences, I wouldn't go there. We had two very good presenters who have talked about this. We are looking at renewable energy integration. Of course, you're looking at your environment impact assessment, carbon capture and storage. For me, in there is that today, when everyone is trying to look green, act green, and be green, you as usually disturb Priscilla because she made a mark on me the first time. You as a mad logger, what do you do in terms of sustainability, in terms of being relevant in that area space? Now, a very good example, I think in Uganda, what we're doing, we have, as a young professional, you look at what is available, what is my current environment, how do I be green, how do I add a green ticket to what we're doing? For us in Uganda, we are seeing the rigs running solar lights. We are seeing them turning the generator power and inverting it into, storing it into batteries and inverting it into power. We have greenhouse emission sensors. We have drones that we do fly around to see if there is any leakage. And of course, those are some of the things that used to be done by the humans. Now, again, I apply it to you. Are you the one running the drone and collecting data, analyzing it and turning it into information? Or you're the one crying, saying, oh, my job has been taken by a drone, so I am erased out. The thing here, in terms of applicability, is how do you regenerate yourself from who you were yesterday to someone new today and be able to unlearn whatever you have learned over the past decade and be able to learn something new and be relevant within the industry. That period of having, I secured a degree in oil and gas, a degree in petroleum engineering, and that is going to be my ticket, no longer works. You have to understand what is happening. Again, in terms of competences, you have to come so you have to come with cross-functional competences in terms of project management, change management, innovations in terms of research and development. You have to look at stakeholder engagement, and of course, you have to look at the financial implications and understanding your financial implications on the sustainability and digitalization of projects, including the rate of return in terms of the calculations you make, and the risks that you are looking at. Now, in terms of policy and regulatory awareness, I urge you young professionals on course and on call to always know what the global knowledge in terms of energy transition, in terms of digitalizations are. You have to be aware of the local, international, and national energy transition emissions and standards. We have what we call the carbon pricing mechanisms. How does that affect you every day? And how do these rules contribute to the tasks you're doing, the courses that you're about to undertake? Are they being phased out? Will it be relevant in the next 5 years? And don't get scared for the next 5 to 10 years, because change is going to make it inevitable for you to get to learn something new. The phones we had a few 5-10 years ago and longer relevant, the computers we had and longer relevant. Same to the oil and gas industry. The technologies we used back then cannot work then, but remember what I told you, we have to incorporate the traditional expertise in the cutting edge technologies to be able to move forward. If you're talking about machine learning, it is like doing exercises every day with your computer to be able to teach it to be able to do the things you as a human being are doing, which is artificial intelligence. So every day you feed it with data, you tell it what to do, you tell it to improve, you tell it you like it or not, and you continuously teach it. And with time, it starts picking the trend, and before you know it, you have a mini you on your computer, understanding how you write your documents, how you interpret your logs, and different aspects. Now, the training gaps, again, if we are to look into digitalization, of course, Africa, we are lagging behind. And for me, having had a chance to work in Ghana for some good time, and then in Uganda, I have been seeing how much we are doing in terms of internet connectivity and access. You will appreciate that today we are looking at only 40% of Africa's population having access to internet. What does that mean when it comes to digitalization in oil and gas? How far do we go back to a student who has not seen a computer all his life until he gets to a workplace? But now even the connectivity is an issue. We have the digital skills and literacy. Then we have government policies and investment. And of course, where we lack comprehensive digital strategies and which show progress in terms of digital transformation. We look at the regulatory framework for data privacy. We look at digital taxation. We look at e-commerce, which are still evolving in many countries, even the development ones. And of course, when we come to the challenges of regulatory aspects and governance, of course, I'm coming from the regulatory side of the oil and gas industry. We are looking at the fragmented markets where we have two, we have, for example, here in Uganda, we have a different body that is dealing with the ICT regulations. We have a different body that deals with national data. We have a different body that deals with oil and gas regulation. So we have different markets that need to come together. Of course, we have corruption and weak governance. Cybersecurity, I talked about it. So what do we need to do as professionals, and what can we do to strategically position ourselves? I can't emphasize enough. We need to start thinking, systems thinking. Yes, we are going into automation, robots and whatnot. How do you, as a human being, as a young professional in oil and gas, start thinking systems-wise? We have to be anticipatory in terms of our competences and skills. We have to be normative. We have to be strategic. Definitely, as the machines take over, we have to learn to be collaborative, because I could code and do a machine that looks at only drilling and forgets all the other aspects. Definitely, it's going to fail. We need to be able to collaborate with other different disciplines to be able to come up with something that is solid and relevant. Critical thinking, that is a given. And the most important one, self-awareness and problem-solving competences. So for me, I think as a regulator, I've come to appreciate things to do with strategic orientation. And I urge you to be able to adopt to place-based education aspects. What works for Russia in terms of digitalization, in terms of energy transition, might not work for Uganda. And where Russia is, or where it started from, maybe we as Ugandans, we don't need to start from there. We have learned from their mistakes. We can maybe do what they call frog leap into at different times. When they were developing the phones, they didn't wait for everyone to be connected to a landline. Even those that had never held a landline are now holding mobile phones. So in terms of the technologies, we don't have to suffer through all that other people have done. Maybe we need to look at where we are as a country, where is Ghana, where is Uganda, and be innovative enough as the young youth and be able to apply our skills and knowledge to what the problem of Uganda is in terms of oil and gas, and be able to create innovative ideas that can help us be able to move forward. They had said we look into future-proof technologies. The thing is, you can't do something which is future-proof. The moment you say, I'm going to design something that will run 30, 40, 50 years, you're limiting yourself in terms of innovation, in terms of creativity, and in terms of adaptability. So for me, I would say that learn to be able to study what is happening, know your environment, and be able to change yourself as a chameleon to suit your environment. That is it in terms of my discussion for this session. I thank you very much.
Thank you so much, Engineer. I really learned a lot from all the presentations. That the underlying idea was to keep yourself updated with all the new changes and then to continually improve, to know that traditional oil and gas knowledge and technology still form the basis as we transition. Thank you all so much for sharing your wonderful insights with us. So now let's have a few minutes of questions and answers. So please, if anyone has any questions for any of the speakers, you can go ahead and raise your hand and we'll give you the chance to speak. Also, just to mention, unfortunately, Dr. Victoria had to leave for another important commitment, and so she'll not be around for this part. Any questions? You can also feel free to put in your questions into the chat box. Okay, I see a hand. Christabel, please, you can unmute and speak. Hello, Christabel, can you hear me? Okay.
Okay, yes, I can speak.
All right.
Yeah, thank you very much. So I have a question for Dr. Yen, and it really is, I want to know what level of collaboration we have within our schools right now in different departments. So taking KNUST, for example, with petroleum engineering and the incorporation of digital tools, do we have any form of collaboration with, say, the computer science department or any other departments that can, so we have that cross-disciplinary learning for students?
Please, can I respond now?
Yes, please. Thank you.
All right. Yes, we do have internal collaborations, very, very strong internal collaboration. So for every department, basically our courses can be split into two. We have courses that we call service courses, courses that are taught by lecturers in other departments. So it's like you are hiring them to come and teach in your department. So our mathematics is taught by lecturers from the Department of Mathematics. Basic mechanics is taught by lecturers from Mechanical Engineering Department. There are times that thermodynamics can be taught by someone from chemical engineering. So that's how we work in the university. So the curriculum that we have designed, the heavy or high demand digital courses are going to be taught by lecturers from computer engineering. We have very good relationship with them, but they will have to do that in collaboration with lecturers in our department, because we don't want the case where the students are just picking the domain programming skills, for example. We want a case where the lecturer teaching the course also has a good understanding of domain petroleum engineering, and the projects that are designed for the students to work on are all solving oil and gas or its related challenges, so that the students can be able to apply it well. So we do have that collaboration. The energy systems courses are taught mostly by lecturers from mechanical engineering, the energy subgroup. They usually handle those courses. Thank you.
Thank you so much, Doctor, and thank you, Christabel. Are there any more questions in the group chat? So I have a question for Engineer Namukasa. I know you have experience with quality assurance and quality control, and this aspect is often overlooked, especially now that quality in the oil and gas industry is now being redefined in terms of the energy transition and all these the data technologies that are in there. So my question is, how can quality control be integrated into oil and gas training for professionals to be able to maintain the new standards of quality in the industry? Engineer John.
Okay, thank you very much, Kevin, for that wonderful question. Quality control is whereby you standardize the way you deliver your systems in terms of what procedures you're following, what processes, and what standards are you following in order to deliver the same product over and over again without or with limited off track or mistakes. Now, the assurance is in terms of not only the shape, but in terms of the materials you've used, in terms of the process it goes through, but also in terms of the way it delivers the things. Okay, if it is a pump, you look at what material has it been made of, what is the size, how fast can it pump, at what efficiency is it going to pump. If it is a meter, we deal with so many meters at different points when you start producing. Now, at what point do we start integrating this in oil and gas? I think by the time a student starts specializing in oil and gas, we actually have to take a few steps back into the high school training or education, which is given to people once the student has a line in terms of engineering, in terms of STEM. We start incorporating it so that it becomes a culture. It becomes part of our lives, that I am given a task X. Am I going to produce the same cover over and over again? So, for example, if you're designing a drill bit for a specific formation, there is a way they have standardized the cutting edges and be able to categorize them differently. But now, if it is being produced in China, are you able to produce it in Ghana with the same specifications, same abilities, same everything? Now, as I said, we go back a few steps into the high school. It has now become a culture. Then we go into the university. where now you're going into your oil and gas. The other one has come from your physics, from your math, from your science. And now you're entering into a specialization of oil and gas. This is a child that is growing into delivering quality aspects, not only in terms of the machines, but even in terms of the work. You know, I keep telling people quality control and assurance isn't only in the operations aspects, is in the way you deliver your everyday work. Coming to work on time has an aspect of quality assurance that people will know that by 8 o'clock sharp, Namukasa is seated on her desk. That is the kind of quality, and she will give her boss the 8 hours full of quality, not going into maybe WhatsApp or going off course. We are humans, we get tired, but what quality control or assurance are you giving yourself as a human being on that human being level from the school and university? So in a nutshell, and to summarize the words, you have to start early enough. We have to start early enough so that we grow into a culture of delivering high quality services, high quality products at all levels within the industry. Thank you, Kevin.
Thank you so much, Engineer John. Quality assurance is the way you deliver your work. Thank you so much. We have a few questions in the chat, so I'll read them. This one, I'll direct it to Engineer Micky. So Ochan says, thanks to the presenters. For an engineering or geoscience professional, how much in terms of digital skills would one need to be able to thrive in the current digitalization environment?
I think, well, if you look at how much you should know, you will overwhelm yourself. I think you should start small, start with what's immediately available to you. So if you're already in the engineering or science space, you're using software to accomplish your tasks. The vendors of these software are probably doing development in your space to tackle problems that other engineers who are using the same software have come up with. What you could start with is, and again, speaking from someone in the IT space, is resolving the manual issues that you face in a day-to-day with the software. It gives you understanding of how the software works and how to troubleshoot IT issues. And then with engaging the vendors as well, if you go to them with whatever problems, well, not the problems, whatever challenges, aspirations, new things you want to try, you challenge them to come up with ways and means to do what you want. And then within your organization, if you talk to your IT team, your digital team as well, let them know you're using these tools to do ABC, but you want to do X, Y, Z instead. You want to try to find efficient ways, a better way to do things. Usually, a lot of digital transformation is driven by users, driven by user need. Sometimes come from the IT people, but really, if we develop things that people have no need for, there's no point. So it usually is developed from users. What you need, what you want to do, that usually drives what we develop and where we head with our efforts. So challenge your software vendors, challenge your IT team. You will learn quite a bit on your from them, and that engagement and conversation between the two of you will guide you in what you should know and what's useful to you.
Thank you so much, Mr. Micky. Unfortunately, we don't have a lot of time, so I'll just ask the one more question in the chat. So Lucy says, I've seen most of your students have research direction with AI and ML components in them. One of the challenges we face mostly in training ML models is the lack of an accessibility to vast amounts of good quality data. Have you faced that challenge? And if yes, how have you tackled it? I think this question is to Dr. Yen.
All right. Thank you. That's a very important question. Data has been very difficult to come by for us because the kind of data that we want is industry data. But our industry doesn't give so much data out. There are some data that we got from the Petroleum Commission on their website, which we have been using extensively for a lot of the work that our students do. But there are also many projects that we do here that the data we are utilizing are not from Ghana. I schooled in Norway, so I have a lot of data from the North Sea. So I do use that as well. But it's a real challenge. We don't have quality data down here because the companies are not very open to working with us in that direction. Maybe this will improve in the near future, but where we are right now, it is really a very big challenge for us.
Thank you. Thank you so much. All right. So we unfortunately we're behind time, so we can't have any more questions, but I know our speakers would be open to having your questions answered outside of this discussion. Again, we want to say a very big thank you to our speakers for taking the time to share their knowledge and insights with us, and for all of us also for participating and cooperating. It was a really, really insightful session. So next on our agenda, I'd like to call on the membership committee chair for the SP Ghana section, Mr. Yao Frimpong, to give us a word.
Hello, Kelvin.
Hello, Abina.
Yes, so I'll be stepping in for Mr. Yao. Unfortunately, he couldn't join us. Yes, so this is a call to everyone. So I believe some are not SPE members. It's a call and an opportunity for you to register and join SPE. So I'll just drop a link. When you click on that link and you read, it shows you the benefits and the opportunities available for an SPE member. So we are all encouraged to join SPE today. Thank you.
Thank you very much, Abina. Also, we'll call on the membership committee chair for Uganda, who is Priscilla, to give us a word as well.
On top of what my colleague has added, it's a pleasure for me to address you as membership chair for Uganda section. And we believe that collaboration and continuous professional development is one of the key in advancing the oil and gas industry, both here and in Africa. So our commitment, you've seen, is in fostering a diverse, inclusive, and knowledgeable community has gotten stronger. We're having more collaborations coming through. So I encourage everyone to participate in our programs, let it be networking with the professionals, taking advantages of the numerous opportunities that SPE has to grow, both personally and professionally. So whether it is the technical workshops, the mentorship opportunities that SPE has, the webinars like this is our goal to ensure that every member can make an impactful contribution to the energy industry and also to their career path. So how are we going to do this? It's going to tell a friend, the people you work with, a friend of a friend to join SPE as a professional member. It is $25. And if you're a student, you have a waiver for 1 year fully covered, and then a discount for your second year. So thank you for your dedication, for being part of the SPE community. I'll give it to you.
Thank you very much, Priscilla. So finally, we would like to call on the SPE Ghana section chair, Mr. Derek Adam, to give us the closing address. Mr. Derek, the floor is yours.
Yeah, thank you, Kelvin. Thank you, everyone. Yeah, this was quite insightful. I really enjoyed myself with all the speakers. Joan, how are you doing? Long time no see. Um, Good to hear from
Hey,
you.
Derek. It's a pleasure.
Yeah, now I worked with Joan years back, and we've been known each other for a while. Thank you, guys. I know Dr. Yen as well personally, and then I work with Micky here in Tullow, so it was very happy to hear from all of you. Really insightful, really enjoyed it. I like what was talked about from all the panelists on commitment for development outside the oil and gas, because the world is changing pretty fast on us. And oil and gas in the past has been one of the industries that's pretty slow to catch up. But things have changed now. We've developed quite a lot of things that gets us to the point where we are on top of our game now, which is very good. I'm happy to hear that there's been quite a lot of good collaborations between the educational institutions in body to try and develop certain courses outside the engineering to fit into what is changing in the globe. So that's pretty good. I'm very happy about that, and I hope that that would continue, and it would get to the point where the industry would keep up with everything that is changing on us pretty fast. Um, Thanks everyone for joining. There's going to be more of these coming up in the next few months, and then we hope that we can be able to help the students as much as possible to expose them to the industry. There's a lot going on. There's a lot happening, and I was happy all the panelists touched on it. The energy transition is definitely going to happen, but not in our time. We will see the signs of it, but in the next 10, 20, 30 years, there'll be a significant change. And as oil and gas people, we try to keep up and then try to play our part as well in that the space. So thank you, everyone. Thank you very much. We really appreciate it. And then we hope that in the coming weeks or the coming months where we call upon you again, you'll be willing to share that knowledge with all of us once more. And have a wonderful day. And that's it from my side.
Thank you, Mr. President. And before we close, we should also invite a very great man from the Uganda section, Mr. Gideon, the chair for Uganda section, to give us a brief word. Mr. Gideon? Okay, let us
Hello everyone. A very good evening to you all, and Masuzemut to our Ugandan friends, and also Mujevaliko, but also to our Ghanaian friends Akwaba. It's an honor, first of all, for us to gather here this evening together, especially as YPs. And first of all, on the Ugandan side, we are very, very, very pleased to in this. It really, really has been very, very insightful, as you've heard from all our panelists and all our moderators. This energy transition, we have to prepare for it, and how we're going to prepare it, we have already been given the tips from everyone that has come before. First of all, learn, and I think that's what SPE is about. It's about learning, because the learning journey doesn't end in school, but it continues throughout your entire life and your entire career. Even post your career, you keep learning and doing new things every day. So this is just to extend a very, very heartfelt thank you to all the organizers, as well as our esteemed guests from Ghana, as well as our panelists. So I would like to recognize a very, very, very special team that is very, very close to my heart. That is the team from the executive team from SP Uganda section, starting with our YP chairperson, Andrew Chirunda, who has been working very hard behind the scenes to make this possible. So please, if you find Andrew somewhere, please give him a thank you for this, as well as our membership chair, Priscilla, who has been our moderator. And I also just want to recognize the presence of some of our esteemed guests. For example, our director, Tato, who has been with us from the very beginning, as well as others who are on the call. I'm also pleased to mention that Engineer Joan is also one of our directors for the SPE Uganda section. So thank you, Joan, for making the time to come on this call and share with us all these great insights. Continuing with that, we have learned a lot from this, and we're going to keep the learning going. So as the Uganda section, we have a lot of programs upcoming. However, the key program we're having this coming, maybe next month, is the visit of Dr. Riverson Opong, who is the new Africa Regional Director. So for us, that is a very, very powerful thing to have our regional director coming in to visit us, and we're going to be the first section that is going to visit. So please, if you see Dr. Riverson, tell him that we are very, very, very excited to see him again this year. He was here earlier this year where he met the students. So this time we're going to go so much towards the professionals and industry leaders. So we're very excited to meet him. And if anyone is coming, please let us know. We're eagerly anticipating you. So I don't want to take any further time. However, just to really, really pass on my my great thank yous to the entire team, our YP chair Andrew, our membership chair Priscilla, and everyone that has been part of this event. Thank you very much, and have a good evening. And over to you, our moderator.
All right. As we conclude, let's move forward. Let's continue to embrace innovation, collaboration, knowledge sharing, and ensure our sustained relevance in our industry. Also to note, the Ghana section will be organizing a breast cancer walk this Saturday on 5th. So whoever in Ghana wants to attend this event, you could reach out to Kelvin and Afua for more information about it this very Saturday for the breast cancer walk. At this juncture, I would like to wish everyone a good night. Thank you for attending. Have a blessed one. Goodbye.
Goodbye.